if you've already got some experience with 3D modelling, whether that be Blender or some other CAD software, and you're looking for something that's a bit more advanced, this is the video for you. What we're going to do today is we're going to model an impeller from a centrifugal compressor. So we've got a few reference images here. As you can see, very, very complex component, with a lot of weird geometry. So what we're going to do today is I'm going to walk you through this step by step. We're going to look at the topology, and I'm going to show you how to keep it clean and how to model it well in Blender. So the first thing to note here is that in a lot of these impellers, you can see the edge of the actual impeller blade is flush with the edge of the hub. So we're going to have to keep that in mind when we're modelling it, and what we're going to try and do here is create this sort of lip as well that just goes over the top of the edge of the blades up here, and then you have the hole for the shaft in the middle. So the first thing we have to do is we have to decide how many blades we want, and to make this a bit more complicated and so that I can show you some extra tips, we're going to go with an 11 blade compressor. So what we're going to do is we're going to come into Blender, we're going to create a circle, and it has to be some multiple of 11 for the amount of vertices here. So what we're going to actually go for, so we have 11 here, we're actually going to go for 99, right? And the reason for that will become apparent soon. But if you come into edit mode and you select the vertices here, as by default, when you scale something, the transform pivot point is the bounding box center. But you see here, because we have a vertex up here and we don't have a vertex in the middle down here, you can see it's slightly misaligned. So this vertex is aligned with this grid here, and these two vertices aren't. There's a bit of extra space. That means if we go to scale it down normally, if we keep scaling it down, you see it starts to become off center, right? So what we're going to do to fix that, make sure that whenever we scale anything, the pivot point is set to the 3D cursor, and then we're going to do this. If you scale it down, you can keep scaling it down as much as you want, and because it's relative to the cursor and not the bounding box center, which is slightly off, it'll maintain the same, it'll be centered effectively. So what we're going to do, we're going to extrude, and we're going to scale it down along the middle here, and then we're going to extrude it upwards, making sure it's locked to the Z axis here. Bring that up there, a little bit further, and then we're going to scale this. But now that it's scaling relative to the 3D cursor, it's going to start scaling upwards. So what we're going to do, S, Shift Z, and that'll constrain it to the Z axis here. So this is the little kind of lip at the top. And again, we're not working off of any direct dimensions or anything like that, because the main point of this tutorial is just to show you the topology. So once you get to the point where you're working on dimensions, you don't have to think about this topology or anything like that. So I'm going to put this down a little bit here, just so we can get this extra sort of connection here. And then we're going to take this edge loop here, scale this upwards, just so we can get the lip at the bottom. Cool, okay, I'm actually going to pull this up a little bit further. Right, okay. So now what we're going to do is we're going to make sure that our topology supports us having this sort of spiral outwards effect here, right? When the blades are in a sort of spiraled orientation, they're not perfectly straight. So usually what we would do is we would just sort of take this and line it up with, I guess it would be like this or this one, and just extrude it down there. But what we're actually going to do is we're going to take this, we're going to extrude it downwards along the Z axis, and then we're going to rotate it around the Z axis like this, right? We'll maybe put this up a little bit further, right? Now we are starting to get this sort of curve inwards here, and what we're going to do then, we're going to scale it on the Z axis ever so slightly, just so that gets brought out a little bit further. And then we're going to do this again, and we're just going to keep doing this and try and make it curve a little bit less each time, because you see here it's at quite a sharp angle, and then it kind of evens out towards the middle here, and then it curves a bit more again once you hit the bottom, right? So we're going to take that to bit there, extrude this downwards, scale it out, make sure Shift Z to constrain it to the Z axis, and then we're going to curve it a little bit less this time. And then as we get to the bottom, scale it again, start to curve it a wee bit here, and then we're actually going to pull this out a little bit, so I'm going to adjust that in a second. So what we're going to do is we're going to take this and just extend it out a little further. And then we can connect this to about there, right? And if you just click one of the edges, hold F like that, it'll just scale around. So we're going to rotate this a little bit just to smooth it out a bit. And there we go. This looks a bit weird, but that's the base geometry. So we're just going to hit shade smooth actually. Then what we're going to do, we're going to go create a bevel modifier, make it to like 0.1 millimeters or something like that. Set the segments to 2. Set the limit method to weight, profile to about 0.7, and then this miter outer to sharp here, right? And the reason we're going to do that is so that we can add an edge weight. So what you do is you select each edge loop that you want to keep sharp, right click, edge bevel weight, press 1 and then left click, and that adds a bevel weight to it. So that basically tells the bevel modifier which edges we want to keep sharp, and that makes it a lot smoother. And then on top of that we can use subdivision surface, and that again smooths everything out a little bit. So now it's just a case of sort of playing with this geometry to get the exact sort of profile shape you want. There we go. So you can just scale each bit separately, just to try, and you can also turn off the modifiers if it makes it easier to see when you're actually modeling inside here. There we go. So that is the base shape without the blade. So you can imagine that's where the hub is. And we've got that sort of curve going on. As you can see, the grooves here, where the Google Lens, okay, where the part was machined out of. So the next thing we're going to do, if you have a look, if you try and add a loop cut along the edge here, you get this abomination, right? The reason that is because we haven't lined up the edge loops outside to the ones inside. So you can imagine as it curves around, if you're trying to add a cut along a specific thing, it curves around and it goes up and then it goes down to about there, and then it curves around again and it loops through multiple times before actually connecting back to the start. So what we're going to do, we're going to get rid of this. Actually, first off, we are going to add 2 extra phases here, just so that we can have these a little bit closer in case we need to mess with the geometry later at the edges, so we keep these quite sharp. Then we're going to take this inside loop here, we're going to delete it. So now that we've deleted this bottom face, what we're going to do is we're going to take one of these edges here, we are going to extrude it out, just sort of in this direction, scale up so we can see it a bit better. And we're trying to find where this loop connects to the edge. You see it goes about 90 degrees around and it connects up there. So what we're going to do, we're going to take this, and we're just going to move it to this sort of direction. We're going to rotate it around. There we go. Hook these up. And then for now, we're going to dissolve this edge, right? And then just select this edge and hold F to extrude it all the way around, or connect it all the way around. So now you can see it kind of really bunches up here, which we really want to avoid. So what we are going to do is we're going to put an edge loop here, make sure it's 3D cursor, and scale it up. And we're going to keep kind of doing this. As you can see, it sort of create the spiral we had on the top, but like inverted almost. Just so that, look at this. Also, you can pull this a bit further down just to get it to curve a bit harder. And there we go. We have this sort of spiral effect going on. So now, if we go to add an edge loop, it just creates one consistent. If we add it here, sorry, you can see it just creates one consistent loop that goes on one face. It comes through the center shaft once and then goes round once, and it just connects perfectly. Cool. So now what we're going to do, we're going to model one of the blades. So we're going to come here. We are going to, actually we're going to turn off our modifiers just so we can see this a bit better. We're going to shade flat, just so we have a bit, we can just see it a bit better when we're working. So we're going to select essentially where we put one of our blades. So this is the sort of blade root. You can see here, this is where the root of the blade is. So we're going to extrude it upwards. We're going to hit Z twice to make sure it's constrained into the global Z axis. And this looks really weird at first, and it's going to look really weird for the next minute or so, but just trust the process, it'll work out eventually. So we're going to take these edges up here, and we are just going to get them out of the way for now, right? Just completely out of the way so we don't have to work with them. Again, that's what I mean about it. It's going to look weird for a while, but just trust the process. We're going to take this edge that we extruded up here. We're going to set this to active element, and then we are going to shift select one of these vertices along here. So that means, oh, sorry. Yeah, we're going to shift select one of them. So we're going to go S, Z, and 0, and we'll scale it down there. And then we unselect this, select this to 3D cursor, S, Shift Z, scale it out like that, right? So we're trying to pull this out here. So we will pull it out a bit there. That's about what we want. And then we can just scale this down normally. And then what we're actually going to do, if we come around sort of here, we're going to rotate it to about there. So it's just about sort of aligned with this. It doesn't have to be perfect. Again, this is Blender, so we're kind of eyeballing it a lot at the moment. We're not working off any specific dimensions. This is just about the topology. So we're going to rotate it around. As you can see how it works here, it's kind of spun there. So now we're going to clean all this up. I'm going to bring this back in here. And now we're just going to put them in a kind of approximate position. And then we can refine it as we go along. So again, you're going to start to get really weird looking topology here, but don't worry, we will fix that. So as you can see here, we're just kind of pulling all of these in into sort of about where they'd go. We can put these two in together just because they're quite close to each other. Cool. So again, keep an eye on your reference photos while we're working on this, just to make sure you're getting the sort of right idea. So we're going to put that in here. We're just going to start rotating some of these around. Pull this up a bit further. Up a bit further again. And now, I'll avoid scaling these, just try and rotate them into position. Just because scaling them can kind of screw up which way your edges go around. So we're going to rotate this here. And yeah, you're going to get some really weird faces here, but yeah, we will get to that in a second. So this is sort of starting to get to the general shape we want. What we're going to do now is if you select these, you can hit Shift V to edge slide. So what we're going to, but you have to make sure you don't slide it down here. You have to kind of, if you look at it at the right angle, you can slide it along these faces, right? So we're going to slide this kind of back and forth, basically, and this sort of averages out the position. And this is a really good way of getting quite smooth edges if you just kind of do this back and forth. Just a bit there, and then you can kind of adjust it from there. So you can just slide this back and forth a bit, and it kind of smooths it out, so it's in between the two that are before and after it. There we go, it's already looking a lot better. But now you can see, because these edges are a lot smaller than these ones, it's like this is kind of translated out here. So this is a lot thinner here than it is here, which isn't really what we want. So we're going to take an edge loop, we're going to pull it close to the bottom here, just to keep the sort of same shape at the bottom. Then we can scale these down, so they're about what we expect. Just again, kind of eyeballing, so that they're all of the same scale, approximately. We can thin out the one in the middle a bit, and this one as well. There we go. You're still getting some weird geometry artifacts here, but what we're going to do now, add a loop cut again, and we are going to add about 4, right? And there we go, we're really starting to get the kind of shape we want. And with this you can even start to screw with this, you can like mess it around if you want. So what we're going to do now, we are going to take this entire edge loop, we are going to create a bevel there, we're going to add some bevel weight like we did before, just set it to 1. And then all the sharp edges on this, we're going to add bevel weight as well. Alright, there we go. Shade smooth, bevel, subdivide. We're going to add it here as well actually. That's the one we've got to add at the base. There we go. I'm just going to see if there's anywhere else we've missed. I don't believe there is. Yeah, okay, that's what we want. Good. So, now, well, I'm actually going to pull this in as well, just because I think that looks a bit better if I start to pull that in. Just so that it's a little, it starts to kind of taper out as it hits the bottom, like that. So, now what we're going to notice, if we have a look here, there is this little crease and it kind of pulls along here, along this face. So what we're going to do to sort that, first of all we're going to add a loop cut there. Then we're going to get rid of this face. So now, what we're going to do, we are going to select this, sorry, select that, select all these. We're going to press I to inset and hit B for boundary, right? then once we do that, we're going to go to the edge loop. We're going to get rid of the bevel weight from the ones we've selected, and then we're going to add bevel weight to here, and then we can start to pull that in. Now, you're still going to get some creases this way, and the reason for that is because effectively these angles here are too sharp. And if you look at the subdivision view, if we go to optimal display, turn that off, you can see sort of all of the edges in here, and it's kind of hard to see because there's so many edges looking through it, but you can see all the edges here kind of clumping together. So what we're going to try and do is we're going to try and make this edge a little bit shallower, and we don't want to pull it in too far this way because it'll start to kind of, well, we can, but it really starts to, basically your topology starts to kind of screw up once you start getting things too close, and then you run into issues with what's it called, the merging vertices from by distance. It'll start to merge things you don't want it to merge. So start trying to pull this down, maybe pull these down a little bit nearby, and then pull these in a bit closer. Kind of screw it. Basically, you can just adjust it until that becomes kind of smaller, and you can kind of move these back and forth as well if you want. So again, it's one of those things that's not too big of a detail. The topology in this case, we'll basically just try to avoid poles here. We'll try to avoid say having multiple faces that join like that, because that would really screw it up. And by the way, the reason that we are adding these bevels here, or these bevel weights here, is because if we get rid of them, this is what you get, and that's a bigger problem. So we can now reconnect this, and if you just like these, hold F all the way around. There we go. So that's our basic blade shape, right? What we're going to do now is we're going to rotate it all the way around. So we want an 11 blade compressor, that's what we set up for. So we're going to come out object mode here, add an empty, any kind of empty works, I just use plain axes, and now we're going to rotate it along the Z axis by some amount. So what we're going to do, 360 divided by, 360 divided by 11. So it's 32.7 degrees. That's a long number, but if you do it specifically, if you type that in specifically, it'll give you pretty much the exact turn rate you want. So we're going to add a modifier to our object here, the impeller. We're going to add an array modifier. We're going to uncheck relative offset. We're going to come down here, we're going to check object offset, and we're going to select our empty. And we're going to set the count up to 11, right? This may start to get a wee bit laggy on some lower end systems because you've got so many vertices here. So what we're going to do, we're going to pull this to the front. We are going to hide our bevel and subdivision modifiers. And we're going to have a look at this. So we have 1, 2, 3, 4, 5, 6, 7, 8 in between here. 8 faces in between. So once we uncheck array, what we're going to do is we're going to have 4 on each side. So we will go 1, 2, 3, 4. We'll select the 5th one. Hold Alt, select this. We're going to delete this face. Do the same on the other side. 1, 2, 3, 4. Select the 5th. Alt, select the 5th one. Select that face. Come to this area that's unselected. Hit L. Delete faces. Then we're going to add our array modifier. We're going to apply that. We're going to come to object mode. We're going to select everything, or edit mode. We're going to select everything. We are going to go to vertex selection, merge vertices by distance, and I'd set this quite low, just so if there's any vertices that are close together but not exactly on top of each other, they won't get merged. So now we can shade smooth, bevel, subdivide, and there we go. This is our impeller. So now we can go ahead and add materials to it if you want. I've got another video on my channel about machine metal material. You can add quick anisotropic behaviour here. If you plug that into there, put that up top of this. I'm just kind of playing with some settings here. You can kind of mess around with this when you want. If we go into world view, we can add a quick little HDRI, and there we go. That is our impeller. So now that we've got a model like this in Blender, Blender's really good at Blender's got a lot of good rendering and animation packages and just kind of tools in general, as opposed to compared to a lot of CAD software. Like a lot of CAD software, you could model something like this, but you wouldn't be able to get some of the details here. Like, see, if we go into our modifiers, you can adjust the bevel here. If you turn this up to maybe 1mm like that, you can start to see you get that shine on the edges. And CAD software is, because it's so precise, it just can't do this sort of thing. It can't do that like smoothness. You can also add individually. You can say hit this, you can control B to bevel it, and you can add like a bit of curve on the edge, kind of whatever you want, right? So this is one of the main reasons I think that everyone who's in engineering should try Blender. I mean, it's completely free, so you don't have to pay anything, especially compared to the prices of a lot of CAD software nowadays. So if you like this video, if you found it particularly helpful, I think you'd really like the Blender for Engineers course that I'm running. It's currently in its beta phase, so if you sign up now, you'll get lifetime access for essentially a lower price than it would be in the future. We cover a full modelling workflow for aircraft designs, taking an aircraft design spec and turning it into a concept model. We also do this sort of thing where we take a CAD model from a CAD software and bring it into Blender and re-topologize it like we've done today, and get it ready for rendering and animations and any kind of project deliverable things you might need. So if this video helped you out, it's the top link in the description. Go check it out. That would be, you'd be supporting the channel, you're supporting me, and you would be giving yourself some crucial skills that you might need in the future.